OK, so ladies and gentlemen, what I want to do is just do a quick little flashback just to Algebra 1. Just remember when stuff now is easy. But back then, it was still might have been a little bit as confusing as it is today. So if I was going to give you guys an equation, let's say y equals x plus 1. And I say, hey, graph it. All right? Now, before you guys even learned about how to graph by writing on your desk, you learned how to, or at least by using slope-intercept form, you learned how to graph by setting up a table. That's the first thing you guys learned as far as even probably like pre-algebra. You guys learned without looking at other people's tests on how to plot points, right? So when you have y equals x plus 1, if I was going to graph this, the first thing that that we teach students is x comma y. And we teach them to go ahead and pick points. Now, remember, when we're picking points, for the x values, it doesn't really matter what points we pick. We're just going to choose arbitrary values for our x, which is our input value. And then we're going to find our output. So remember, this is like the input, and this is the output, right? So you'd plug in your values to find the output. So when x equals -1, you have 0, you have 1, 2, and 3, right? And then we can plot those points and graph, right? Everybody make sense? Good? Everybody remembers that? So then the next thing we kind of talked about, going a little bit more into input and output, is we talked about a function. And that's really why we use that verbiage as input and output. Because remember, a definition of a function is when you have that input value, you're going to have a uniquely exactly one output. So we use this notation f of x equals x plus 1. And we made sure that we need to understand that we have an input and the output. And we rewrote that with the f of x rather than y. All right? Now, when we graphed, before, when we did x and y, we had a y-axis and we had an x-axis, right? But then once we started talking about functions, we changed the y-axis to this output axis, which was just called f of x. Exact same thing. Nothing changed except the way that how we named it. Because when we were talking about functions, we knew they had special properties, right? Function, you know, vertical line test, the unique output values, and so forth. All right? So what I asked you guys to do, I don't like that eraser anyways. What I asked you guys to do is determine some of these values. All right? And I gave you a couple values, cosine of 0, cosine of pi halves, cosine of pi, cosine of 3 pi over 2, and blah, 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 blah. All right? So what I'm really trying to get with you guys is, let's say I had a function f of x equals the cosine of x. Well, therefore, what values I have here that I'm plugging into here are what we're going to call our input. And the answer that we're going to get out would be our output. So we can create a table of these values. So we can write x and f of x. Let's see if I can divide this correctly. So we had 0, pi halves, pi, 3 pi over 2, 2 pi, 5 pi halves, 3 pi, 7 pi over 2, and I messed up. I need one more, and 4 pi. OK? Now we just need to determine what the output value is, right? So that's what I asked you guys to try to do without kind of talking about input and output. So to find the output, one thing I noticed is each one of these angles, if I was going to evaluate for sine and cosine or tangent, each one of these angles intersect the unit circle at a point on the unit circle that we know of. So let's go back to the unit circle then and try to see, well, where is it then these angles are? So when we first drew the unit circle, the main thing that I talked to you guys about is the unit circle has a radius of 1. The loneliest number, right? 1. There you go. See? Good. So this point is 1, 0. This point was 0, 1. This point is -1, 0. And this point is 0, -1. Right? 4 points. These other points, those are the tricky ones, right? That you guys still probably are still trying to like remember and trying to get through, like, because they're so like pi over 3, square root of 2 over 2, like all this crazy stuff that going through. But those are with your special triangles. Now, thankfully for right now, I'm not really going to be dealing too much with them. All right? So what we have here is we know that if we start our initial angle, we know that halfway around the circle is pi. Now, when we talk about an angle that intersects the unit circle at pi, we know that, remember, the cosine of your angle, t or theta, whatever you want to call it, represents the x coordinate of that point on the unit circle. Correct? Correct? Correct. OK. So let's look at pi. The output value, then the x coordinate of pi, is going to equal what? -1. OK. Now, let's go ahead. If that's pi, then we know that over here is going to be pi halves, right? And we've already talked about this. So therefore, pi halves is going to be, so the x coordinate there is 0. And then let's go back even to cosine of 0. That means I haven't moved anywhere. So the cosine of 0, the x coordinate is 1. All right? Fair enough? So now let's just continue on. If this is pi halves, that's 2 pi halves, which is pi. 2 pi halves. So then here would be 3 pi over 2. So the x coordinate at 3 pi over 2 is 0. Then we have 4 pi over 2, which is the same thing as 2 pi, which is 1. Then we keep on going. This would be 5 pi over 2, which is 0. Then we go back to 6 pi, or 3 pi, which again, it goes back to -1. Then we go to 7 pi, which again is 0. And then we come back again to 4 pi. Now, I stop at 4 pi. But if you guys, if I was to continue this pattern, would you guys have any reason to believe that the values are going to be anything different than 1, -1, 0? No, it's going to just continue on and on and on forever. Remember I just kept on reciprocating and stuff like that when we raise it to a power? Well, this is going to be very similar. There's no other values that we're going to get when we keep on just trying to find those values. Yes? No, it works for sine, cosine, tangent, cosecant, secant, and cotangent. But for right now, we're just going to deal with cosine. And cosine and sine are very similar to each other. And that's why I was telling you we're going to investigate cosine right now, Jamie. But sine is very, very similar to it. OK? And you could do this exact same problem, exact same, but just change it to sine. And the sine values would be a little bit different, but the pattern would be exactly the same. All right? So all right, so we're at this point. So now we found our points. So let's write them in there. So our output values are 1, 0, -1, 0, 1, 0, -1, 0, 1. And the other thing I want to mention, you guys, as I keep on going around and around and around, is there any stoppage to this? Just going to keep on going, right? I can keep on doing coterminal angles, going revolution, 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 revolution. And these points are going to keep on going. So now, let's go ahead and graph it. Why not? Because now we have a table. Yes? So let's do it. Why not? Why not try to see, well, what would this look like as a graph? OK? So what we have is we have an output, and we have an input. All right? Now, when I'm looking at the output values, ladies and gentlemen, the output values only go up to 1 and only go down to -1, right? There's no other difference. So when I'm scaling my y-axis, I'm only going to scale it from -1 to 1, right? Yes? Everybody understand that? Yeah. But now, when I'm looking at the input value, I got all of these values to kind of go through. So I'm not going to want to scale it 1, 2, 3, or 4 when my outputs are in terms of pi. Correct? So what I'm going to do here, let's just go ahead and we'll start at 0. And then I'll do pi halves, pi, 3 pi over 2, 2 pi, 5 pi halves, and then 3 pi. I'm not going to continue the whole thing, but I'll continue at least to 3 pi because I'm running out of space. But however, if I went in the positive direction, could I also do the unit circle in the negative direction? Yeah, so why don't we just do negative pi halves, negative pi, negative 3 pi halves, negative 2 pi, negative 5 pi halves. Yes?
So why did you take the x coordinate and put it in f of x? When you were doing the circle?
Yeah?
You took the x coordinate and you put it under f of x.
put it under f of x. Remember, when I'm evaluating a cosine, the cosine of an angle is equal to the x-coordinate of a point on the unit circle. So it's not equal to x, it's equal to the x-coordinate of the point that it intersects on the unit circle. Okay? So this angle is not equal to x, it's equal to the x-coordinate of the point on the unit circle. That's what I was representing with that difference in there. So when I say, hey, what's the cosine? Let's say this. If I say, hey, what's the cosine of 30 degrees? Well, 30 degrees, that's equal to the x-coordinate of where 30 degrees intersects the unit circle. And the cosine where x intersects the unit circle is going to be square root of 3 over 2. So that would be your answer. Okay? But we're not getting into those ends. So it equals not x, but it equals the x-coordinate. Okay? All right. So now, ladies and gentlemen, let's plot our graph and see what this graph looks like. So we start at 0. At 0, we have 1. At pi halves, we have 0. At pi, we have negative 1. At 3 pi halves, we have 0. 2 pi, we have 1. 5 pi halves, we have 0. At 3 pi, we have negative 1. Interesting. So my graph looks something like this. OK? Cool. Very cool. Not really. It's OK. Now, let's go ahead in the other direction. If I was just going to continue this pattern. Hold on. Hold on. Hold on. If I was just going to continue this pattern, I would have something over into there. OK? So we'll finish off the rest of this when you guys return.